Consider a pulse wave moving through a medium. What happens to a pulse when it reaches the end of that medium? The answer depends on whether the medium is fixed in space or free to move at its end. For example, right now it is at a fixed end, and as you see, the animation depicts a behavior which is referred as inversion. The pulse becomes inverted upon reflecting of the fixed end. That is, the pulse with an upward displacement will reflect of the end and return with a downward displacement. This inversion behavior will always be observed when the end of the medium is fixed. When there is a loose end, you'll see how the pulse reflects off the free and returns with the same direction of displacement, which it had before the reflection. That is, a pulse with an upward displacement will reflect off the end and return with an upward displacement. Sometimes it is said that a pulse is not inverted. This behavior of non-inversion will always be observed when the end of the medium is free to move. When there's a reflection of a plane surface, there will always be a normal, which will be perpendicular to the surface. Then there's an incoming ray with an angle of indecence, and which will be reflected back with an angle of reflection. The law of reflection tells us that the angle of indecence will always be equal to the angle of reflection. Another way to see these is through the wavefronts. As here you can see, here are the rays, but also there are these lines which are called wavefronts. And as you can see in here, they are reflected and they are also perpendicular to the rays.